Okay, I hope you had a chance to work through example 4, and you can check your answers with my answers, at least for all the subgroups of the 8 generated by 0, 1, 2, 3, 4, 5, 6, and 7. So I wrote them all down. And so now we can see if we can generalize something again. So in example 3, we found that some of our elements, group elements, generated the whole group, and the same thing appears to be happening in this example as well. We have a few elements that generate the whole group. So we have 1, 3, 5, and 7 are all generators. We can write that down. So the group generated by 1, 3, 5, and 7, they are all equal to each other, and they happen to be our entire group, the 8. And do we have any other groups that are subgroups that were equal? Here, the group generated by 2 and by 6 are actually equal to each other. So we also have these two groups, subgroups, are equal to each other. And we observed something similar in the previous example. So let's zoom out and see if we can look at both of those together. So in both cases, we generated the whole group with some of our elements. What do you notice? Do you notice anything that they all have in common? 1 and 5, what do they have in common when our operation is addition mod 6? And 1, 3, 5, and 7, what do they have in common when the operation is addition mod 8? Well, they have in common that they are all relatively prime with the order of our group. So 1 and 5 are relatively prime with 6, and 1, 3, 5, and 7 are all relatively prime to 8. So we could write this down. So note that when we are looking at the greatest common divisor of 1 with 6 and 5 with 6, they're the same, and they're 1. That's interesting. And the same thing we are observing in our group, the 8. So I'm going to write that over here to the right. We have that the GCD of 1 with 8 is the same as the GCD of 3 with 8, is the same as the GCD of 5 with 8, is the same as the GCD of 7 with 8. They're all relatively prime, those pairs of numbers. And so the GCD of 1, 3, 5, and 7 with 8 is 1. And that generated the whole group. So that's observation number 1. And then, is there something similar maybe that we can observe when we are looking at the elements that generate the same subgroups? So 2 and 4 have the same greatest common divisor with 6 when we mod out by 6. And 2 and 6 have the same greatest common divisor with 8. So we can write that down too as something to notice. So the GCD of 2 with 6 is the same as the GCD of 4 with 6. And it's not 1, it happens to be 2 in this case. And we have the same thing happening in the 8. So the GCD of 2 with 8 is the same as the GCD of 6 with 8. That also happens to be 2. Now, there are more things that you can observe here. So if you are observing some other things, maybe looking at orders of groups, looking at generators, looking at GCDs, see if you can notice anything else and take note of that. And we're going to look at example 5 together in the next video, and then we're going to try to come up with some theorems that summarize some of these observations that we